Energy is one of the true constants of the universe, because as long as there's been universe, there's been energy. And while it comes in lots of different forms that can seem different to us, they all amount to the same thing. Energy is the ability to do work, and work is just the act of displacing something by applying force. Well, in this video I will explain the concept of two types of energy, kinetic and potential energy. So, the first question you might ask yourself is, what are these two energies and what's the difference between them? It was in the 17th century, polymath good friend Leibniz who first figured out the mathematical form of kinetic energy, which is the energy an object has because of its motion. And it depends on the velocity of that object as well as its mass. This means that if two objects with different masses are moving at the same velocity, the more massive one will necessarily have more kinetic energy. And now, let's discuss potential energy, which is forever intertwined with kinetic energy. And potential energy is the energy that is stored in a body due to its position or its configuration. And here, we distinguish two types of potential energy. Elastic energy, and is the energy that is stored in elastic materials such as springs or rubber bands. And gravitational potential energy, which is the energy that's within an object when it's moved against a gravitational force. When we hold this ball on one side, it has a certain amount of potential energy that depends on its mass as well as how high it is above the surface. So, in this position, kinetic energy equals 0, while potential energy is different from 0. When the ball is released, potential energy starts getting converted to kinetic energy. But in this first try, the barrel doesn't fall. Then, we take it further and leave it. It topples the barrel. And it means that more we increase the displacement of the ball from the mean position, more the velocity at which it hit the bottle increased. Thus, the kinetic energy contained in the ball increased too. And now, let's do another experiment to show you the effect of mass on energy using this bucket of water and these two balls to determine how much potential energy they have because of the gravitational pull by measuring how tall their splashes are. Well, we throw the little ball into the bucket. Its splash is so small, it's approximately 27 centimeters. Alright, next is the football. We drop it from the same height and its splash is higher than the first one because of its mass. It's almost 80 centimeters. As you can see, this diagram is in form of an increasing curve whose splash increases with the increasing mass. So, we conclude that a heavier object will have more gravitational potential energy. This experiment is to clarify more and more the converting from potential to kinetic energy. In the first case, we change the mass, so we conclude that the more mass, the more kinetic and potential energy we have. Then, we change the height using the same mass and we deduce that the higher ball clamps, the more energy it has. The total energy of a closed system is always conserved. As an object falls, potential energy is converted to kinetic energy, but the sum of potential and kinetic energy will be the same at every instant during the free fall. We call this sum the mechanical energy of the system. As a conclusion, this table summarizes the points of difference between kinetic and potential energy, and remember that the energy cannot be created or destroyed, it can only be transformed from one form to another.